Alright guys, let's see how we can solve another question from the chapter 4 of engineering mechanics by Meriam, and we have this wingnut B of the collapsible bucksaw that is tightened until the tension in the rod AB is 200 newtons. So we have the tension in the rod AB, so this rod first of all will be in tension, and we know that force is 200 newtons, and we need to determine the force in the saw blade EF, so in this one, and also the magnitude of the force supported by the pin C. So as always, we're going to be treating this question as an equilibrium, so we're going to have three different equations: sum of all forces in X, sum of all forces in Y equals 0, and we're going to have one moment equation as well. And what we're gonna do in here is that we're gonna draw the free body diagram for this member, and let's just show it in here. And we're gonna have 3 points in here that we have forces applying in these points. So first of all, from the top part or the member AB, we know it's in tension, which means the force that is applying from this rod AB to this member has to be in the opposite direction. So this is the correct direction for member AB, and we know it's 200 newtons. And again, these two are in the opposite direction. Based on the Newton's law, it has to be the same force in the opposite direction and same magnitude. So that's why we need to watch for this, based on the fact that in the question we know that member is in tension. So we have two more forces that are applying in here. We can consider one force FCD and one force FEF. But one thing we need to keep in this, one thing we need to keep in mind in this is that these two forces are two force member, because we have one force applying at each end, which means the force in these two members will be along the line that connects these 2 points, or for CD these 2 points. So we discussed before that if we have a pin, we need to consider two forces, one horizontal and one vertical. But based on the fact that we have a two force member, each of these forces is going to be vertical. So I'm just going to consider one direction for now, and we're going to see if it's correct or no. Let's just consider FCD in this direction and maybe this direction for EF. Let me just color X and Y in here. So it makes sense to start with, so this is A, C, and F. E. Makes sense to start with our moment equation about point C, because that way we can get rid of the FCD and we should be able to find the FEF. And we also know that this angle here, 25 degrees, which means this angle here is also 25 degrees. So we're going to have the moment of the FEF about C, which is going to be in this direction. So we have a counterclockwise moment. FEF is our force. And we need the vertical distance from C to the line of action, or this distance, which is basically the 160 millimeter that we have in here. So that's that. And we're going to have the moment of 200 Newton about C. This one's clockwise, so it's going to be negative 200. And the distance that we're going to have, it's going to be the vertical distance from C to the line of action of the 200 force, or what's in here, which is basically 80. And this will be equal to 0. And I didn't do any unit conversion for millimeter in here because it won't make any difference in our equation. So basically our FEF is going to be, we can cancel a 1, 0, 1600 divided by 16, which is going to be 100 newtons. We didn't get any negative signs, so that shows that is the correct direction for member EF. So we figure out the member, the force in the saw blade EF. And now that we have this, we just have to do sum of all forces in X equals 0 just to find the other force that we have, which is FCD. So we're going to have 200 plus FEF is 100, and we consider FCD to the right. So we'll be positive. What we're going to get in here is that the FCD is going to get a negative sign, which shows that the correct direction for FCD is actually to the left. And yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.